AS level maths, so A level maths, year 12 and year 13, and also AQA level 2. Okay, just see further maths, looking at differentiation, okay, of some functions. Okay, we've got a composite functions and a fraction in this video lesson. Differentiate with respect to x, giving each term in its simplest form. Part A, 1 minus 2x all squared. Now, if you're in year 12, okay, you probably haven't seen the chain rule yet. So I'm not going to do that one in this video, but basically I can write it out as a pair of double brackets and then expand the bracket, okay, using FOIL or the grid method or the arrow method. Okay, so I'm doing 1 times everything in the second bracket and then minus 2x times everything in the second bracket. So 1 times 1 is 1, 1 times minus 2x is minus 2x, minus 2x times 1 is minus 2x, okay, and then minus 2x times minus 2x makes positive or plus 4x squared. 2 times 2 is 4, x times x is x squared. I'm now going to collect my like terms next. So we're going to have 1 minus 4x plus 4x squared. I'm now going to differentiate the function. So I'm going to work out f dash of x or dy by dx. Okay, so differentiating this, okay, part A is going to go to, well, 1, any constant has to go to 0, minus 4x goes to minus 4, okay, and then 4x squared, the power comes down as a multiplier. I'm going to reduce the power by 1. So we do plus 4 times 2 is plus 8. Attach the x, and then we knock 1 off the power, okay, and that's equal, yeah, to the derivative, okay. So d by dx of 1 minus 2x, okay, all squared, okay. Now, if I was in year 13, obviously teaching this, I could have adopted, yeah, the chain rule, okay, which, yeah, I might do this pretty quick this year, which is the power comes down to the front as a multiplier. So we have 2 at the front, okay, and then 1 minus 2x, and then we knock 1 off the power, so it becomes power of 1, okay. Obviously, anything to the power of 1 here is just itself, so we don't need to actually put that there. And then we multiply by the derivative of what's inside the bracket. So we multiply that by minus 2, okay, because 1 goes to 0, minus 2x differentiates to minus 2. But if I tidy this up here, 2 times minus 2 makes minus 4. So I get minus 4 bracket 1 minus 2x. And then if I expand that bracket, I will get minus 4, okay, plus 8x, which is what I've got here, okay. But again, at this stage, yeah, I think the first method is probably more accessible to most students. Okay, write it out as a pair of double brackets, expand using FOIL, collect your like terms, okay, and then differentiate as normal, which is, yeah, the rule is the power comes down as a multiplier, and then I reduce the power by 1, or I knock 1 off the power. Okay, what about part B, guys? We got x to the 5 plus 6 root x all over 2x squared. So at first glance here, yeah, it actually looks pretty nice because I've got a fraction here. But because I've got a single term on my denominator, I can split this, okay, into 2 separate fractions. So I'm going to have x to the 5 all over 2x squared, okay, plus 6 root x, or 6 lots of root x. Now I'm going to write root x here as power of a half here just to make it a bit easier, all over 2x squared. Okay, so hopefully we are all in agreement now. Okay, so as long as I have a single term on my denominator, I can split this into 2 separate fractions, okay, whether it's an addition or a subtraction there. I can do it. What next, guys? Well, let me just put it down here actually, okay? I'm going to now see tidy it up. So I've got 1 over 2 at the front, so 1 half or a half. I've got x to the 5 and I'm dividing it by x squared. Well, I'm going to subtract my powers using my index laws. So I'm going to have half x cubed. Then we're going to have plus 6 over 2 makes 3. X to the half divided by x squared. I'm going to subtract those powers, those indices, because I'm dividing with the same base. The base here is x. Okay, when I'm dividing with the same base from GCSE and Key Stage 3, we subtract those powers, we subtract those indices, we subtract those exponents. Okay, so a half take away 2, so be a bit careful. 2 is equal to 4 halves. A half subtract 4 halves makes minus 3 halves, or negative 3 halves. Okay. Again, if you're unsure, check it on your calculator. Okay, I'm now going to differentiate this. So d by dx, okay, is going to give me, so the power comes down to the front as a multiplier, and then I knock 1 off the power. So we're going to have a half times 3 makes 3 over 2, or 3 halves. We attach the x, and then we knock 1 off the power, it becomes 2. Next up, we're going to do a very similar process. Plus 3 times minus 3 halves is minus 9 halves, or 9 over 2, or negative 9 halves, or negative 9 over 2. Attach the x, and then subtract 1 from the power. Minus 3 halves minus 1 is minus 3 halves, subtract 2 halves, which makes minus 5 halves, or negative 5 halves. And that's my answer for part B. Okay. So part A, the answer is minus 4 plus 8x, or if it's factorized, is minus 4 brackets 1 minus 2x, or minus 4 brackets minus 2x plus 1. And the second one, when I differentiate it, I get 3 over 2x squared, or 3 halves x squared, subtract or minus or take away 9 halves x to minus 5 halves, and that is my final answer. Okay, hopefully that made sense. But yeah, this is aimed at year 12 and year 13s for A-level students for the pure math section, looking at differentiation. Okay, first year A-level maths. Okay, although as I said, yeah, at the start, yeah, part A could have been done, yeah, using the chain rule. Okay, if you've been taught that, okay, unlike you have, and then part B could also be done, yeah, using the quotient rule. But there's no point in doing that because that becomes quite long. Okay, but yeah. Part A could have been done here with the chain rule, and part B could have also been worked out or done using the quotient rule. Okay, I'll let you practice the quotient rule if you want. Okay, or prove that you get the same as this answer.